On Thursdays, I will do exclusively problem solving, okay? And I will start with some example problems from chapter 1, which was about measurements, significant figures, and dimensional analysis. So here's our first example problem. It's about dimensional analysis. The period T of a simple pendulum can be expressed like this. Here, this capital T is the period. If you remember the definition of period, it's the amount of time required for one full cycle. K times L to the N, G to the M. So what are these? K is a dimensionless constant. It's a number, okay? No dimension. L is the length of the pendulum, okay? Şeyin uzunluğu, sarkacın. And G is free fall acceleration, okay? Gravitational acceleration. So we know that this period depends on K, okay? Some constant, the length of the pendulum, and free fall acceleration. We just don't know how, okay, how this dependence is. So we wrote the most general expression, okay, L to the N, G to the M. Now the problem is to find those numbers, N and M. Then I will have a form for this period expression, okay? I will do this using dimensional analysis, okay? So this is my equation, T equals KL to the N, G to the M. Fine. I check the dimensions of both sides. I know that the dimensions must be the same, okay? If left is apples, right side must also be apples. So dimensions, dimension of period is T, okay? By the way, this T and this T are different. This T stands for the period. This T is dimension time, okay? So don't be confused. In here, K is a dimensionless constant. So it has no dimension. It just disappears. We don't care about it. L is the length of the pendulum, okay? So its dimension is, of course, length. Pardon. Its dimension is length, right here. See, this L to the N is the dimension of this L to the N. And for G is acceleration. Its unit is meter per second square. So its dimension is length divided by time square, okay? And it had this exponent, M. Then the dimension of G to the M is L to the M times T to the minus 2M. So this is an equation for dimensions. For it to hold, exponents on both sides must match. Umarım şu an hani yaptığım işlemi hepiniz yapabiliyorsunuzdur, yani o matematik bilginiz vardır. Lütfen beni durdurun ve anlattırın, tamam mı? Çok önemli, çok temel bir şey yapıyorum şu an çünkü. Okay, so this equation to hold, exponents on both sides must match. Okay, so t to the 1, here there's a 1, must be equal to minus 1 must be equal to minus 2m, okay, which will immediately give me the value for m, okay, here it is, right here, minus 2m must be equal to 1. On the other hand, for L terms, I have an exponent of n plus m for the right-hand side. If you look at the left-hand side, there is no L term, which means that actually there's an L, but its exponent is 0. Tabii ki solda da bir L var diyeceğim ve üssü 0. Tamam. Çünkü L üzeri 0 1'dir ve denklem sol taraf sağlam kalıyor. In this case, 0 is equal to n plus m, as shown here. two conditions. This second one immediately gives me the value of m. It is -1/2. And when I substitute that value here, then I will get n as +1/2. See? I substitute these values to the primary expression here and here, then my final result. Period of simple pendulum is proportional to, never equal to in dimensional analysis, proportional to square root L, okay, because it is L to the n and n is 1/2. 1/2 kareköktür. L'nin karekök demektir şurası. And here g, because g's exponent is m, which is -1/2. Okay. Any questions about this? So this was my example about dimensional analysis. Now I move to chapter 2, motion in one dimension. In this chapter, we learned concepts of position, displacement, velocity, speed, acceleration. Okay. We also learned about scalar and vector quantities. Now, in this example, this is the position versus time graph for an object. Okay. And we are asked to find the average velocity for different time intervals. For example, what's the average velocity for between 0 and 2 seconds? Here and here, okay? Let's find out. This graph gives me the position of the object. So when t equals 0, object's position was also 0. When t equals 2 seconds, here object position is 10 meters. So that's the final position, and this is the initial position, okay? Then, to find the average velocity, first I need to evaluate the displacement, okay? Divided to the amount of time, and there it is, the average velocity. Here's the calculation. Delta x divided by t, displacement. Displacement is xf minus xi divided to the amount of delta t, 2 seconds minus 0 seconds, and there it is, 5 meters per second. In the first 2 seconds of the motion, the average for the first 2 seconds of the motion, the average velocity is 5 meters per second. Part B, do the same calculation, find the average velocity. This time for between 0 and 4 seconds. Okay. Bu sefer 0 ile 4. saniye aralığı için bulunuz ortalama hızı. Geometrik olarak da gösterirsek 0 şurası. Here is t equals 0 and here's the fourth moment. This is the position. So asked quantity is the slope of this line. Şu çizdiğim çizginin eğimi soruluyor size. Let's find out. Slope of this line, which has the physical meaning of average velocity, is delta y divided by delta x. Okay, delta y is like 5 meters, I guess. Here it is. And delta t is 4 seconds here. Here it is. So result is 1.2 meter per second. Okay. 1/2 metre bölü saniye. Şu kırmızı çizginin eğimi. Birinci kısmında sorunun eğim veya ortalama hız 5 metre bölü saniyeydi. Bakın farkı görüyor musunuz? Şu çizginin eğimiydi. Bunun eğimi 5 metre bölü saniye. Bunun eğimi 1.2 metre bölü saniye. Dik eğim, alçak eğim. Sayılar nasıl değişiyor? Continue. This time for interval between 2 and 4 seconds. Okay. So where is it? 2 seconds, it's here. And 4 seconds, it's here. So my points are this one and this one. The slope will be the slope of this line. Şu çizginin eğimi. For this line, okay, for this part of the motion, delta y ya da şey hani displacement is final position, which is 5 meters, minus the initial position, which is 10 meters, divided by delta t, which is 2 seconds. So it is minus 2.5 seconds. See how they have different signs. When your line has a slope like this, it's a positive slope. When it's like this, it's a negative slope. Okay? Eğimi artı eksi. Part D. 4 to 7 seconds. So where are they? 4 is here and 7 is here. Then it's the slope of this line. Huh? Is this correct? 4. saniye ile 7. saniye arası. Şu çizginin eğimi. Here and here. So displacement is pardon yanlış çizdim. Şurası. Şöyle. Şunun eğimi. 4. saniyede de şurada. I expect this slope to be higher because this is a steeper line. Daha dik bir çizgi, eğimin daha büyük olması ve daha negatif olmasını bekliyorum. C şıkkındaki sonuca göre. So, final position is this, minus 5 meter. Initial position is this, plus 5 meter. Okay, their difference is this, minus 5, minus 5. Delta t is this, 7 minus 4. Okay, result, minus 10 over 3. Minus 3.3 meter per second. Here it is. See, it's steeper compared to this one, previous value. Bir öncekine göre daha dik eğimi. And finally, find the average velocity for the whole motion. Okay? So what's the whole motion? It starts here, object starts here, and ends here. Oh, it ended where it started, right? Which means that displacement is 0. Okay, delta t is 8 seconds, so average velocity is 0. But what can you comment about the average speed? Ortalama sürat sorulsa ne derdiniz? O da 0 mı sizce? Average speed is calculated, you know, as in a somewhat different way. To calculate average speed, you need distance traveled. Okay, yani alınan, kat edilen yol önemli. And the distance traveled here is definitely not 0. It is 10 meters plus 15 meters, okay? It made 25 meters plus another 5 meters. So distance traveled here is actually 30 meters. And to find average speed, you need to divide 30 meters to 8 seconds. Okay, that's your average speed. Let me see if it's made. No, we didn't do that calculation here. I wish we did. Onu ekleyeyim. Okay, any questions? Yeah, by the way, we have that, we will be doing that calculation here, average speed calculation. Can you hear the noise? There's some noise here, but is it like, is this microphone picking it up? Şu an bir gürültü geliyor da şeye geliyor mu mikrofona? Okay, that's cool. I think it's because this is like not a general directional microphone. So next question. A person walks first at a constant speed of 5 meters per second along a straight line from point A to point B, left to right, okay? And then back along the line from B to A at a constant speed of 3 meters per second. Here it is. First to the right with 5 meters per second speed, constant, and then back the same distance, this time with a lower speed, okay, 3 meters per second. Question, what is her average speed over the entire trip? Ortalama sürati nedir? And part B, what is her average velocity over the entire trip? Maybe we can start with part B, huh? The average velocity, because it's easier. What do you think? What's her average velocity over this entire trip? Bu yol boyunca ortalama hız nedir? Buna hemen yani cevap verebilmeniz lazım. Average velocity is 0. Why? Because there is no displacement. The motion ends where it started. Yani ortalama hız 0 bu harekette. Derste anlattığım, verdiğim örnekle aynı sebepten. Buradan Ankara'ya gittim ve geri geldim. Ortalama hızım kaçtır? 0. Niye? Çünkü ortalamamız yer değiştirme bölü zaman olarak bulunur. Yer değiştirme sadece baştaki ve sondaki noktalara bakar. İkisi aynı. Yer değiştirme 0. Ortalama 0. Ortalama sürat farklı bir şey. Alınan yol, kat edilen yol. Distance traveled divided by delta t, okay? Which is not 0. For example, in this example, it will be distance from A to B, okay, plus the same distance because we're going back. So twice the distance between A to B divided by the amount of time this motion takes, okay? So to answer this question, part A, I need to know the time it takes for these two motions, okay? Let's calculate. Average speed is the total distance or distance traveled divided by total time, which is distance from A to B plus distance from B to A. They are equal. It will be twice of either of them. But what is this? I don't know what this is. I need to calculate it, okay? These are time needed to travel for the passenger, for this person to from A to B plus the other way around. Let's do the calculation. Yeah, this is the first thing. Of course, they are equal, the distances. Now, for these times, to calculate them, I will use this simple expression x equals vt. X eşittir vt'yi kullanacağım tabii ki. Bu onun şey hali, hani zaten sadeleştirilmiş, yer değiştirilmiş hali. This is x equals vt. I hope you can see that. So using that expression, we can find t, right? Divide the distance to your speed. And similar calculation for the other part of the trip, okay, the return trip. Let's go on. The average speed is, okay, this expression now with t values substituted. It is 2dAb, twice the distance between points AB, divided by these time terms, okay? Here, as you see, there's a cancellation. The distance between points A and B are cancelled out. They're not relevant to the answer. You can notice this situation from the question itself. There is no mention to this distance, okay? No numerical value given, because the result doesn't depend on it. Anyway, we simplify this expression, okay, evaluate these fractions, and so all we get is the velocities. See, a combination of them, And we do know their numerical values. When we calculate them, you find that the average speed is 3.75 meter per second. Okay. So that's the result. And this is what we already discussed, part B of the question, average velocity being 0. Any questions about this problem? Sorunuz var mı? So, next problem. By the way, almost all these problems are from survey, okay? They are the chapter end problems. So, you can also check from there. Now, a particle moves along the x-axis according to this equation. We are given a function of the position as a function of time, okay? Where x is in meters and t is in seconds. Now, at t equals 3 seconds, at a certain moment, find the position of the particle, its velocity and its acceleration. Belli bir an için diyor, bu parçacığın konumunu bulun, hızını bulun, ivmesini bulun. Before we start, just by looking this expression, this formula, what can you say about this motion? Bu hareket hakkında bir yorum yapabilir misin? Sadece şuna bakarak. Ne tür bir hareket bu? Kategorileri hatırlayın, 2 kategori. Motion with constant velocity, motion with constant acceleration. What type of motion do you think this is? Yeah, okay, it says find the acceleration, but it doesn't mean it does accelerate. Okay, maybe the acceleration is 0. That's also a value, okay? To answer to this question is, just by looking at this expression, you will learn a lot for this motion. Remember that formula, x equals x0, initial position, plus v initial t, right here, vi t. So I think the initial velocity of this object is minus 3 meters per second, plus 1/2 at square. Yani o 1 bölü at kareli şeyi canlandırın kafanıza, denklemi. Aynen bunu da düşünün, şöyle bakın. Üst üste koyarsanız neyin ne olduğu anda ortaya çıkıyor. Ne tür bir hareket olduğu da. Here, this is 1/2 at square term, right? Therefore, the acceleration is, I think, minus 2, right? When you put minus 2 to 1/2 at square, then you get this. Let's find out. Let's continue. Okay. For this certain moment, what's the position of this particle? We just put t equals 3, wherever we see t here. There you go. 2 comes here. 3 times 3, okay? This is t. Minus 1.9. Here, this is, sorry, this is not 1.9, this is 1 times 9, okay? So, you calculate this, you get 2 meters. That's the position of the object at t equals 3. Part B, let's find the velocity. Şu türev kısmını örteyim önce. So, to find the velocity, since I'm giving a function, to find the velocity, I need to differentiate it with respect to time. Make sure you can do these differentiations, okay? It's a very trivial differentiation. First term, I expect to vanish. It has no t dependence, it's constant. Second term should give me 3. T, derivative of t is 1. And for the third term, I expect to get minus 2t, okay? Because this exponent 2 should come here. This t should become 1. And so 2 plus 3t minus t square. Oh, t square. Ha, şu orijinal halini burada var şu an. Henüz türevin alınmamış hali. Alınınca işte bunlar çıkıyor. Here it is. Dropped becomes 1, 3 here. This 2 comes here. It becomes minus 2t. Next step, evaluate this expression for t equals 3 seconds. Here, this is your velocity. Minus 3 meters per second. Important thing about this problem, what I'm trying to demonstrate to you in this problem. Finally, the acceleration. To find the acceleration, you need to differentiate position twice with respect to time. But we already did differentiate it once to find the velocity. Then here it's a function of time. So I will differentiate this once again to find acceleration. In this differentiation, this term will be 0. Here, this t will go away, so it should give me minus 2 meters per second square. Okay, that's the acceleration. Acceleration is constant as expected. Okay, remember our discussion. When we looked at this formula, this function, and try to guess what kind of motion this is. It is motion with constant acceleration, okay? And here it is. It is motion with constant acceleration, and the value is minus 2, okay? There is no mention of time. It's constant. Any questions with this problem? So the next one. Oh, somewhat related problem. Related to the previous one. Each of 4 particles move along an x-axis. Their coordinates as function of time are given by, whoa, we have 4 functions, right? Just like this one. We are given 4 functions. Question, which of these particles have constant acceleration? 4 parçacıktan hangisi veya hangileri veya belki de hiçbirinin ivmesi sabittir? Ne dersiniz? We will do the same trick, okay? We will imagine that expression 1/2 at kareli olan denklemi düşüneceğiz. Benzerliğine bakacağız. These two, as you see, are exactly like that. See, I have a constant term. This is xi, initial horizontal position. See, başlangıç konum yani, x0. Here I have a t term, 3.4t. Therefore, this is v0, initial ilk hız. Eksi 3.4'müş bu 4. parçacıkta. Şunda hiç öyle bir şey yok yani, terim yok. İlk hızı 0 demektir bu. And these t square terms are acceleration terms, okay? Constant acceleration terms. Yani 1/2 at kareye karşılık gelen şeyler. Mesela 1/2 a eşittir 2.7. Demek ki ivme 5.4 metre bölü saniye kare şunun için. Bunun için de öyle ama yönü eksi mesela. Okay? So I can read the motion just by looking at those functions. Now, how about these guys? What do you think about them? Is this motion with constant acceleration? They are not. Now I'll show you why. I won't show you why. Just differentiate them twice, okay? 2 kere türevini alın. Bakın bakalım buradaki bir sabit bir sayı çıkıyor mu? Bakın burada 2 kere türev alınca eksi 2 çıktı sayı. Yani içine hiç t yok, tamam mı? Size sorarım. Eksi 2.7 t küpün 2 kere türevini alırsanız kaç çıkar? You will get minus 2.7 times 3 times 2, okay? Times t. Yani 2 kere türevini alınca illa bir t kalacak geriye. Which means that you get something, you get your acceleration, okay? But it has a t term. It depends, your acceleration depends on time. It changes with time. Which means that it is not constant. Okay? So, You differentiate them twice and check if they are constants. 0 is also acceptable. It's also constant, okay? The answer is particles 3 and 4 have constant acceleration. Any questions? Can you follow? Takip edebiliyor musunuz dönen şeyi? Anlattıklarım. Next question. We have a racing car traveling with constant acceleration. It increases its speed from 10 meters per second to 50 meters per second, okay, over a distance of 60 meters. How long does this take? So, as I told before, first thing you need to do in every mechanics like kinematics problem is define what kind of motion this is to categorize it. So this is already said, it's motion with constant acceleration, okay? So you know your formulas, you know what to use. Now, I'm asked to calculate time, okay? I have information of position over a distance of 60 meters, okay? I have initial velocity and final velocity. So I can use a number of equations. If you remember, we had 3 equations, okay, which were related to position. Bir böyle 1 bölü 2 VI artı VF'li olan vardı. Ondan sonra bir 1 bölü 2 AT kareli olan vardı. Bir de zamansız hız formülü vardı. 3 tane. You pick the one that fits best to your interests, to your problem. For example, for this problem, this one is the best. See? XF equals XI plus 1/2 VI plus VFT. Why is it the best? Because, see, this formula has no A term. Çünkü ivme terimi içermiyor. Bilmiyorum çünkü ivmeyi de, tamam mı? Ama zaman var içinde. There is also initial and final velocities and positions, okay? I can just take this 0 as the origin. Then this XF will have 60 meters as value. VI and initials will have values of 10 meter and 50 meter respectively. T is my unknown. So, you pick the correct equation, you have very easy problems. T is 2 times XF divided by VI plus VF. Evaluate your result. This motion happens in 2 seconds. Okay. 60 metre 2 saniyede alıyor. Doğru denklemi seçerseniz bir vuruşta indirirsiniz. Yoksa ya ivme neydi? Önce bir ivmeyi bulayım, sonra ivmeden öbür t'yi çekerim falan filan. Bazı denklemlerde kare almak falan filan gerekiyor. Bakın ne kadar yalın bir şeyle çözdük. Doğru şey seçimiyle. Okay. Any questions? So, next one. A particle starts from rest and accelerates as shown in the figure. This is a T graph, okay? This is also an important example. It's intended to demonstrate you to work with graphs. Grafiklerle sonuç bulmayı size göstermek amaçlanıyor. Eskiden üniversite sınavına girerken dershaneler böyle acayip her türlü böyle bu tür kinematik şeyler hep grafiklerle çatır çutur halledilirdi. Şimdi durum hala öyle mi bilmiyorum. Onun bir kalıntısı gibi diyebilirim size. Ama tabii ki çok pratiklik ve işimizi gören bir şey. Bilmekte büyük fayda var. So, this is the AT graph. It shows the evolution of acceleration of an object versus time. See, in the first 10 seconds, the object has acceleration of 2 meters per second square in the positive x direction, okay? And then see, there's this, in this region, the object moves with zero acceleration, which means that the object is moving with constant velocity, okay? Hızı değişmiyor demek cismin 10. ve 15. saniyeler arasında. Sabit hızla hareket yapıyor. İvme 0. And then suddenly, in this 5 seconds, between 15th and 20th seconds, the acceleration changes direction. See? Also, its magnitude becomes larger compared to this part. Now, it's like minus 3 meters per second square, okay? In this for these 5 seconds. Maybe you can interpret this like this, this graph. You're in your car. For 10 seconds, you hit gas pedal. İlk 10 saniye boyunca gaza bastınız. Bakın ivmeli gidiyor araba. Hızlanıyor yani. Then for 5 seconds you release the gas pedal. Okay. Gazı bıraktınız. Artık hızlanmıyor. Neyse hızlı o hızla gidiyor diyelim. Tam öyle olmaz gerçek hayatta. Hani öyleymiş gibi şey yapalım. And then for 5 seconds you suddenly hit brake. Okay. Tam eksi yönde ivmeleniyor yani. Böyle düşünebilirsiniz bu hareketi. So what's the question? Okay. Find the particle speed at t equals 10 seconds and at t equals 20 seconds. And so that's part B. Let's find this first. What's the speed of this particle at t equals 10 here, at this moment? Okay. Now you can use the velocity expression, okay? By the way, it starts from rest, so initial velocity is 0. Okay. So you can use v equals at. T is 10 seconds. A is 2 meters per second square. Then the velocity will be 20 meters per second. Okay. So that's formula. Now I will do the same calculation in a more geometrical way. Okay. Rule is şurada. The rule is area under the AT graph gives delta V. Okay. Şurada bir daha çizdim. AT grafiğin altındaki alan hızdaki değişimi verir. Nüansa dikkat edin. Hızı verir demiyorum. Hızdaki değişimi verir. So this area, which can also be negative, it's negative here, okay? This area is a change in the velocity. So find that area, multiply 10 with 2, then the change in velocity is plus 20 meters per second. Same calculation I did here, okay? Tabii kutu olunca, kutu pense yani hesap kolay. Ama bu üçgenler, yamuklar falan filan olunca ve bir sürü değişik hareket yapınca parçacık, o zaman o hesaplar yani formüllerden yapması o kadar kolay olmuyor. Grafikten yapmak daha kolay o zaman. Ki bunun devamını da göstereceğim onu. Şimdi birazdan hızı bulurken göreceksiniz durumu. So, 10 seconds, velocity is 20 meters per second. Right here, as shown here. Bakayım şurada. 20th second, when t becomes 20 seconds, then delta V is this area plus this area. It is 20 meters per second. Also, there is this area, but the area of that part is 0, as shown here. The area of this part is 5 seconds multiplied by 3 meters per second square. It is minus 15 meters per second. Okay, so you add them, all of them. This is your final velocity. Başta gaza bastınız, 20'ye çıktı hızınız, 20 metre bölü saniyeye. Gazı bıraktınız, 20'de kaldı, değişmedi. Frene bastınız, 15 metre bölü saniye eksildi hız ve son 20. saniyedeki hızınız bu, 5 metre bölü saniye. Okay, now I'll give a break. Any questions? If not, we'll continue after the break.